I'm Dr. Narayanasamy, retired professor from Department of Production Engineering, National Institute of Technology, Tiruchirappalli, Tamil Nadu, India. I'm going to talk about cold working and annealing. What is cold working? Cold working is a deformation carried out under conditions where recovery and recrystallization processes are not effective. What is hot working? Hot working is deformation under conditions of temperature and strain rate such that recovery and recrystallization processes take place simultaneously with deformation. Usually, cold working is carried out at room temperature, whereas hot working is carried out above recrystallization temperature. Warm working is in between cold working and hot working. Warm working temperature is between cold working temperature and hot working temperature. Let us discuss about cold working. The structural changes during cold working of polycrystalline metals and alloys are given here. Changes in the shape and the grain size. The epoxy grains are elongated in the direction of the maximum principal strain or in the direction of the maximum principal stress. For example, rolling direction, the direction of rolling and wire drawing operation. This figure shows the structural changes during cold working operation. This is before This is the microstructure before working operation, cold working operation. Here, this alloy exhibit this steel, almost steel. This exhibit 90 hardness value of 95 Vickers hardness number. During cold working, grains are getting elongated. Grains are getting elongated. After severe work hardening, after severe deformation, the grains are getting elongated. Only you can see the grain boundaries. You can see the grain boundaries. Here the hardness value reaches to from 95 to 155 Vickers hardness number. Changes in the orientation of the grains. Preferred orientation or texture is the state of severely cold work material in which certain crystallographic planes of the grains orient themselves in the preferred manner with respect to direction of the maximum principal strain or maximum principal stress. Changes in the internal structure of the grains. During cold working, around 15% of the work of the deformation gets absorbed in the material. Rest is lost as a heat. The stored energy is the form of energy of the crystal defects. Plastic deformation increases the concentration of point defects. With increasing cold working, the number of striking fault increases, thus the density of the dislocation increases. Because of dislocation interaction, the number of kinks, jogs, dipoles, prismatic loops are increasing. The dislocation density increases. In the most of the annealed case, the dislocation density is in the order of 10 power 6 to 10 power 8 centimeter minus 2. Whereas in the cold work, moderately cold work material, the dislocation density varies from 10 power 10 to 10 power 12 centimeter minus 2, power minus 2. Effect of cold working on properties. Cold working or strain hardening or work hardening is the increase in stress. Nothing but increase in stress required to cause further slip because of previous plastic deformation. This is an important industrial process that is used to work harden or harden metals or alloys that do not respond to heat treatment. For example, aluminum alloys, you take 1000 series and 5000 series, it will not respond to heat treatment process. So it can be cold work and annealed. It can be cold work and annealed. For example, mild steel, you take mild steel also can be cold work and annealed. During cold working, various mechanical properties, it changes the various mechanical properties, physical properties, and chemical properties of the metals and alloys. With increasing amount of cold working, ultimate tensile strength, yield stress, hardness increases. However, or but the ductility, elongation, percentage area reduction, or formability decreases. Cold work texture and mechanical fibering. Cold work texture and mechanical fibering leads to anisotropy in the properties of material. The ductility impact toughness is much lower in the transverse direction rather than in the longitudinal direction. This figure shows the property changes during cold working and annealing. On the y-axis, property is taken. X-axis, cold work percentage is taken. As the cold work percentage increases, strength and hardness keep increases with increasing amount of deformation. However, the ductility or formability decreases with increasing amount of cold working. Whereas in the case of annealing, as the annealing temperature increases, the formability or ductility keep increases like this. Strength property decreases with increasing annealing temperature. Similarly, hardness also decreases with increasing temperature. The internal stored energy during cold working is very high. This is chemical reactive. The reactivity of the material increases. This makes that the chemical reactivity of the material increases. For example, corrosion resistance decreases. This may cause corrosion, stress corrosion cracking in certain alloys. The rate of strain hardening is generally lower in HEP metals rather than cubic metals. In the HEP metal, number of systems are less, so strain hardening is not much. Whereas in the case of cubic metal, number of systems are more, so work hardening is higher. Strain rate hardening is higher compared to HEP metals. Higher temperature of deformation also lower the rate of strain hardening. Annealing of codework materials. In certain applications, materials are used in codework state to derive benefits of increased strength and hardness. The codework dislocation structure is mechanically stable. However, it is thermodynamically unstable. It is necessary to restore ductility to allow for further cold deformation. To restore the optimal physical properties such as electrical conductivity, annealing must be carried out. The treatment to restore ductility or electrical conductivity with simultaneous decrease in hardness and strength is called annealing or recrystallization annealing. It is nothing but heating coatwork material to a temperature above recrystallization temperature, holding there for some time and then slow cooling. Annealing. The process of annealing can be divided into three stages, namely recovery, recrystallization, and grain growth. There is no change in the composition or crystal structure during annealing operation. The driving force for recovery and recrystallization is the stored internal energy, whereas for grain growth is the energy stored in the grain boundaries.